Hello there, it's Jay here from Jay's Vintage Junk, and today thought we'd take a quick look at this. This is something that my mate Andy gave me, I think he gave it me before Christmas. Apparently the story goes, he had two of these in for repair, and the chap I think said he could, if he got one working he could keep the other one, and he fixed the other one. I don't think there was anything greatly wrong with it, and he said, did I want this? Normally it's not really hugely my kind of thing, but it is really rather a nice looking unit really. I'll just apologise if you hear anything in the background. My cat is kind of running rampant in here at the moment, so do apologise if there's any noises in the background. But anyway, yeah, so I did think it was rather a nice looking unit. Basically it's a powered speaker, and it also has a wireless phone charging capability on the top there. And I just thought do a quick video, see if we can actually get this thing working again. It's not really my kind of thing, but I do know someone that would probably quite appreciate this for the living room. So anyway, let's have a quick look round it and see if we can find out what exactly is wrong with this thing. Now, Andy has been in it already, because he gave me most of the screws for it in a bag there. We've got the fixed mains lead, power switch on the back there, and straight away it does appear, yeah, we've got an auxiliary input and a USB there, and they look out of alignment, so I don't know if Andy's had that board out and just pushed it back in. I'm not sure whether that's actually the issue. I would normally just plug this thing in and see what it does, but I'm not sure what state it's been left in, whether this thing's disconnected or not. I mean, we just saw with when I did the soundbar that I've got on my desk here, it wasn't all as I first thought when I opened it up. So I'll grab a screwdriver, we'll get the back off it, and we will have a quick squeeze inside it, and we'll take it from there. What we're actually going to do, Phillips here. I suppose one great thing is I don't have a load of screws to take out, they've already been done for me. Right, let's us see, I've got another screw there, and that's the back off. Right, let's have a quick look. We've got a couple of wires off there, apart from that it doesn't look too much. Let's connect these back up and we'll just grab my glasses. Oops, I have to be careful there. We've also got a ribbon cable there which if we're not careful we'll pull that out. Got rather nice looking down here a little bit so you can see a little bit better what I'm showing you. There we are. It looks a little bit better quality really than the T-Bow one that I've got on the bench here. We've actually got what seems to be quite a decent proper power amplifier there with some nice heat sinking on it. Separate power supply board there, and I'm guessing all the logic will be underneath there where all the controls are. Hence why we've got that ribbon cable there. So first things first, I'll grab my glasses so I can see what I'm doing. I'm not that bothered about, I think that'll just be audio, that one, but we'll connect it back up. But that 2-pin there, I'm not sure what it is. That could be possibly power or something like that up to that unit. So we'll connect that back up. Get my glasses out. Okay. I mean, the power supply doesn't look terrible. I can't see anything bulging or blown on there. That doesn't look too bad. That board's loose. The screw has been taken out there by the look of it. Right, let's reconnect these wires. That one goes there. And that one plugs in there, I think. There we go, so that's powered back up. Everything else seems to look okay on there. Let's stand that back up. Turn it back around. Let's plug it in. In fact, first things first, let's check the fuse in the plug. It should have a plastic cover over there, so if I do get this working, I will have to find a cover there, or cut that plug off and just put a standard rewirable plug on it, because it's not really acceptable to have that left open like that. I mean, it's no problem if it was something I was keeping for myself, but if it's something I'm going to be giving to someone, then I don't really want to leave it like that. Let's get the test meter out. Just got this on continuity buzz. Okay, there we go. Just check that fuse. Yeah, the fuse is fine. Okay. We'll plug it in and switch on, see if we get anything. Right, so seems pretty dead. Hang on, there's not a power switch on the back. Try that in the on position. No, so it is pretty much dead. Yeah, it does feel fairly dead, that. Right, let's switch off again and we'll unplug. Right. There wouldn't have been any fun if it just worked though, would it? Right, let's see what we can find in here then. Let's get that panel off. Oops, right, and first thing I'm going to do is disconnect that ribbon cable before I rip it. So I very nearly did that then. Unconnect that audio connection there, and that one we had there come out, and that connection there can come out. Right, so we can actually get the board flat down on the bench. In fact, what I'll do, I'll just quickly pause the video and I'll see if I can get a better shot so you can actually see what we're looking at here. So back in a sec. Okay, there we go. Hopefully that's a little better so you can see what we're looking at here. So it is a fairly nice unit, this. So we've got obviously that looks like we would never get in there though. Just looking at the controls on the actual cabinet, it's all sealed and glued in place. I don't think we'd ever get that out, so hopefully the fault is somewhere down here. If it's not, then this thing is just a source of some nice speakers basically, and a nice power supply if the power supply is good. And you know, there's other bits I can salvage off it, like that heat sink, but not a huge amount else, to be honest. So hopefully, like I said, the fault's going to be somewhere down here. And the first place I want to have a look, I think this thing's been dropped. This corner here of the PCB there, it's actually missing the bit of wood that should be underneath that leg there. It's actually broken away. So like I say, I'm wondering if this thing was actually dropped, and we've also got some damage underneath there. Excuse me. So first thing I'm going to do, I'll disconnect where the power is. I have got it unplugged. So this is the mains input there. We'll get that disconnected, and we'll see if we can actually get inside in there and see what's going on. We've got basically disconnect this connection there. We've also got a screw, and I don't know if Andy's taken these screws out or whether these screws have come out, because it's been dropped and they've just knocked loose. Right, so that's out. We've got an audio connection here. We can disconnect that. That's out. Right, we should stand a chance of getting this part of the unit out now. There's a couple of screws there. Let's get them screws out, and then we can have a good look. Right, if you can, I'll just tilt the camera up so you can see. I've got an apprentice on the bench at the moment, watching what I'm doing. Providing he stays there and he isn't too much of a pain, I'll leave him there. Right, let's carry on. Right, let's see if we can get in and see what's happened here. Now unfortunately they do like the hot glue when they're making units like this, and they haven't made things easy. But I don't know if they've actually left us enough room to be able to get this unit, to get this out. So we can pull it out this way. Right, there's a screw down there, which, so we've got, I'm missing a screw, that's why I can't get it out. I'm a silly idiot because I've forgotten there's another screw here. Let's take that one out. There we go. So we are missing one of those screws. But when I say we're missing those screws, I've got this bag of screws that Andy gave me with it. So let's have a quick look in there. I think some of the missing screws are in here. Yeah, look. I think we've got probably, there might be more screws than there actually for this thing in here, but that's looking promising. We'll put them over there. And now I think we can actually get this unit out. Yes, we can. That's better. Right, we can actually see what we're looking at here now. So that should basically fit in there, and it's been knocked free. First thing we need to do really is some basic checks. Let's get the mains plug, and what we want to do is we want to check continuity from the neutral pin to basically one of those two connections there, and from the live pin to the other connection there. If we've got them, we ascertain that the switch, the cable, all that is good. And then we know that the fault is actually going to be like either on this board or that board, or it could possibly be somewhere up there as well. So that's the next thing we want to do, is just check that, see if we've got continuity between them points. Bear in mind that we do have a switch as well down there, so let's just make sure that switch is actually in the on position, which it is. Switch the continuity meter back on. See if we can get a pin. Can we get a good connection on here, or we'll have to swap to my other probes. I think that should be okay there. And then we can go, anything there? No. There we go. So that's showing that the live connection from the plug there, from the pin right through the fuse, right to where it actually goes onto the board of the switch mode power supply. So we know that's good. Let's try the same on the neutral side. So we'll go into there, I'll connect on there. Again, yeah, there's absolutely nothing wrong there. So we're getting power all the way to there, which means that we should be able to be getting power actually on the power supply board. Thought there was something there. I thought that cap there may be blown, but it's not. It's just some of the glue that they use to actually seal these things down. Right, so the next thing we want to do, we'll reapply power, and we'll see what voltages we've actually got coming out of the power supply board here. And actually, even if I can't fix this thing, it's got quite a nice little switch mode power supply built into it. What we've got a plus 9 volt rail there. And we have got a plus and minus 18 volt rail there. So this would be great for building my own little amplifier. Having the plus and minus volt rails there is quite nice. Rather than using them modules, I like them little modules from China quite a lot. But sometimes I like playing about with building my own transistorized amplifiers, and having a plus and a minus volt rail power supply opens up a lot more possibilities for designs. Right, so like I said, that even if I can't fix this, that's a useful little thing to have. So what we want to do, we'll set this to the 20 volts range, because that will cover the 18 volts, the minus 18 volts and the 9 volts. Right, we'll connect this back up. we go. And we'll see what we've got coming out here and going into the actual amplifier board. Okie dokie, right, we need to plug that back in. Where's the plug? There it is. Plug that back in and switch it back on. So I have to be a bit careful now because obviously, you know, there is live mains voltage somewhere on that board. It should just be over on this side here. Right, let's see what we've got coming out. I will then just have to quickly get up and let the cat out of here. Right. Now that should be, we should have 9 volts on there, and we've got 2 point something, so that's not right. Let's have a quick look on this main rails of the power supply. Again, we should have 18 volts there, and we've got, sorry, we should have minus 18 volts there, I think, and we've got nothing basically. Let's try the other side, and same again there. So we obviously do have a fault on the switch mode power supply. Just bear with me a second, folks. I've just got to let the cat out of the door. Come on, out you go. The reason I had to keep him in here is because I was feeding the dog, and if I don't watch the two, the cat tends to eat the dog's food before the dog can. So I just had him in here while the dog ate his food. Right, so yeah, we've definitely looks like we've got a problem on the actual power supply board, which is unfortunate, but let's see if we can do anything about it. Hopefully it's not anything too terminal. I've got to admit I'm not a big repairer of switch mode power supplies, but let's see what we can find anyway. What I'll do is I'll pause the video, I'll pull this thing out, and I'll just have a quick squiz around it, and then I'll come back if I can find anything or I can pinpoint anything. So back in a sec. Okay, folks. Basically, what I've ascertained, there is actually nothing wrong with the power supply. Unfortunately, the fault is on that board there. If you look here, basically what all I've done, I did go ahead and test, just quickly check with the meter, the diodes and things like that. Everything, basic checks on the switch mode power supply, things I could. I then powered it back up, and I checked DC on the main capacitor there, and I was getting about 380 volts DC on there, so that seemed absolutely fine. So I just thought, I just unhooked the 2 supply rails there from the actual amplifier module, and if we actually check on it now, I've got this set to the 200 volt DC range because it's floating a little bit higher than the 18 volts it should be, obviously, because it's off load. But if we have a look here now, if I go on the centre pin, which is the ground pin of the main connector there, and then I go on to the what should be plus 18 volts, you can see there we're getting 22 volts. If I go on the minus side, minus 22 volts there, you see that? There we go. Oops. Bit tricky for me to get on it, and we'll have to go down a scale on the meter now, but if I go on the other 2 connections, this was the 9 volts. I'll go on there. Oops, I've gone there. You can see there we've got 9.2 volts. So the power supply itself seems to be okay. It certainly seems close enough. Let me just switch off and use the switch on the back there to turn it off. That should be powered down now. We can just ascertain that we'll go back onto the 500 volt scale, and we'll just quickly measure across the main capacitor. This hopefully has got a bleed resistor on it, so it should bleed the power away. Let's just double check that. Well, there's still quite a charge on that capacitor there. You can see it is discharging, but that would still give you a nasty bite. And just keep the meter on that until that dissipates away to something that I consider safe. That's why you have to be incredibly careful around switch mode power supplies, especially if you have to work on them live. because that one capacitor there, especially if it's quite a poorly designed power supply, so there's some bleed resistance on there, but not a lot. It did take quite some time for that 300 or so volts to bleed down then. We'll have a look there. That is that's safe now. That's bled down to nothing now, so we're happy with that now. Right, unfortunately, like I said, it does look like our fault is on the module board there, so I suppose I'll have to pull that out and have a look at it. So let's take this out. Unfortunately, I'm not too hopeful now about effecting a repair on this thing. Although, like I say, it is giving us some rather nice components which can come into something else. Right, there we go. Let's take this out. So I can't see anything obvious. There's no blown traces or anything like that on there. I can't see any blown capacitors. There's no visible signs of distress, but that doesn't mean anything. I think we've got some pretty beefy output modules under here, so let's take this heatsink off and have a quick look. Have a quick look what we've got. Unscrew out. I don't think Andy had gone this far with it because there's still hot glue on the tops of these screws. There we are. That took some going. There we go. Pull that out. Yeah, see, we've got some surface mount. This thing has obviously got very, very, very hot because all the, and we can make that out there. You can see that there. It's basically conformal coating type stuff that they use to put over some of the components. And if you look, it's like that reddy colour there. The closer we get to these two output modules, and it's black. It's been baked hard, that, by the look of it. I am just going to quickly check these capacitors. They don't look leaky and they don't look bad, but with the amount of heat that's been produced, it could be that we've got a dried up capacitor that's gone short circuit. It's not impossible, to be honest. I don't think so. I'm pretty sure that one of these or both of these output modules here have fried. In fact, they've got so hot even the heat shrinks, even the grease, the thermal grease is basically baked on. It's no longer thermal grease. This thing has run very, very, very hot indeed. I don't think there's going to be a lot of hope for this. Let's have a quick... We will just quickly check some of these for shorts. Let's see if we've got any short capacitors, but I'm not holding out a lot of hope now for this thing. I'm just seeing what useful components we can salvage from it, to be honest now. Let's have a quick look which ones we're looking at. It's probably going to be... If there's any that are bad, it might be them two there. So we're just looking for a shorted cap. No, that's okay. That one's okay. They're charging, they're not completely shorted. Two small ones there, we can just quickly check. Now, let's try it that way around just to be honest. There we've got a shorted capacitor. That's definitely shorted. So that's that one there. We've got a short circuit there. Let's see, have a look on the other side there. That is them 2 points there. Let's quickly try there. I think we might have a short there as well. Let's just keep that there. Yeah, we'll pull those, I might just pull those two capacitors out and actually check them on the capacitance tester. So what I'll do is, I've not got the soldering iron set up yet, so I'll quickly set the soldering iron up and I'll pull them two capacitors out and we'll check them out of circuit. So back in a sec. Okay, well unfortunately my suspicions are confirmed. I've pulled one of the capacitors out and there's nothing wrong with the capacitor. It's fine. That's basically what you get, just connect it across a test meter. But if we go on the pads on the capacitor, where the capacitor was, we can see we've still got a dead short there, and it is a dead short. And unfortunately I've followed the tracers through, and basically that goes right to the output module there. So basically it's what I thought. This thing's got far too hot at some point. So all the thermal grease here has baked, completely baked, and it's just fried the output modules. They're just cooked. I'm not going to be going into trying to bother replacing them or anything like that. It's just not worth it for something like this. These won't be massively mega expensive new. So really it's just a case of what parts I can salvage from this thing. So what I'll do, I'll take a look round it and I will come back when I've taken out the parts that I've decided to keep, and I'll give you some reasons why I've decided to actually keep them. So back in a sec. Okay, and here we have all the parts that I have salvaged. Now this lot here, that is just going to go in my scrap PCB bin. I won't throw it away, it will literally just go in my scrap PCB bin. I've got a big box that I basically keep all stuff like this in. Quite frankly, it's just handy for things like these connectors. The connector on the board. Not so much the capacitors on this one because of how hot it has got, although possibly, you know, things like they maybe still be okay. I can just test them. But these connectors are really handy. The inductors, there shouldn't be anything wrong with those inductors there. Just other little bits and bats on there that are handy to keep. Even the wire can be useful. There's a connector there with its wiring loop, its harness and everything, you know, that is handy to have. So that, like I said, that'll just go in my scrap PCB bin. Apart from that, obviously the power supply, we know that works fine. It's a good dual rail ground, plus 18 volts, minus 18 volts, plus we've also got the useful 9 volt DC output on it there. So that will just, I've got a box basically of useful switch mode power supplies, just bare boards like this that I've salvaged from various things over the years, and they're just handy for experimentation, they're handy for doing, you know, repairs on other equipment and stuff like that, so that can go in there. The speakers, obviously, they seem quite nice speakers, none of them are stuck or anything, so I haven't tested them fully, but none of them feel bad. I've even kept the enclosures for the little drivers there. What I'm actually planning, I'm not so much sure about the sub, but those, I fancy some rear speakers for my truck. It's only got a bit of a cheapy, nasty radio in it at the moment, and I have got better car stereos with 4 channels, so I was thinking about perhaps using them and mounting them possibly in the back of my truck just for a little bit of extra audio. So, you know, speakers are always useful to keep if they're in working condition anyway. Big bag of screws, I'll probably sort that out and they can go into the respective bins, but there's all kinds of useful sizes of screws. We've got the screws for mounting the speakers and things like that in there as well, so always handy to have. Apart from that, we've got that fairly decent heatsink there. Again, if I'm experimenting with something, I need to cool some power transistors or something down. Very, very handy. A couple of ferret rings. Nice little power switch. That will go in my switch box because, like I said, just handy to have for replacements on things then. Then we've actually got the mains lead itself, and in fact this has actually got a use pretty much straight away. I've been asked to repair a DAC90 Model A valve radio, and that kind of radio, they actually had a removable power cord that used 2 pins on the back of the radio, and the radio is actually missing from it, and as well as that, one of the actual pins has been broken off, and they're not a particularly safe connector anyway, and he does want this radio for use. So I think we've got a good modern mains cable there. I will have to find a carrier for the fuse to put a proper fuse carrier in there, but I should have one of them in a scrap box. But nicely, it's got the proper grommet on it as well. We've got a proper restrain grommet, so I can put a little plate on the back of the radio to replace the original connector and drill a hole for that actual proper modern restrain grommet to go in. So like I said, that's going to find a use pretty much straight away. So that is really, like I say, it was a bit of a shame that it wasn't worth repairing the actual unit itself, but in one way I would have just had a speaker unit which I didn't really have much use for. I'd have probably just either give, well, like I say, I did know someone that might have liked it, but it weren't worth throwing any money into it. And in this way I've got some really useful parts that can go into other projects and go into other repairs. Anyway, I'm going to leave it there for now, because I know this video wasn't like vintage radio, vintage computer related or anything, but it's still useful and interesting. You saw a few fault finding techniques and stuff like that. Anyway, I'm going to leave it there for now. I hope you enjoyed this little video, so thanks for watching and goodbye.